In today's video, we are going to cover some integration topic. For the purpose of discussion, I have taken AS Math 9709 February-March 2023 paper. In this question, we have been asked that a curve whose equation is x is equal to y squared plus 1, and there are 2 points, 5, 2 and 2 minus 1 that lies on the curve. Now we need to find the equation of the line. Y is equals to mx plus c. In this equation, we have m as our gradient and c as our intercept. Now, what is m? Change in y over change in x, that is y2 minus y1 over x2 minus x1. This is x1, y1, and this is x2, y2. It is your choice. You can make this as x1, y1, or you can make this as x1, y1. The answer won't be affected. Now, let's plug in the value. So 2 minus and minus 1 over here as well. So minus 1 divided by 5 minus 2. This would become 3 upon 3, which is 1. Now our m is equals to 1. So y is equals to 1x plus c. Now we need to find the value of c. If I want to tell you what is c, c is this thing. So we have to find c with the help of our coordinates, which are these coordinates. So either we can plug any of the value, either a or b. So I'm going to plug a. So 2 equals to 1 times x, which is 5, plus c. And c is equals to 2 minus 5, which is negative 3. Now, we can see that our curve was going toward negative axis. Now we can see that our value of c is correct because it is in the negative axis. So our equation would become y is equals to 1x or just x minus 3. So in this question, this was quite a simple question. In this question, we were required to find the value of equation a, b, and we were given points x is equals to y squared plus 1 and the other 2 points. And with the help of gradient, and y-intercept, we plug in the value of these and find the equation. I hope this question is clear. Now, in the second question, he's asking that find the volume of revolution. Now, what is volume of revolution? And it is rotated about y-axis. Okay. So what is volume of revolution? Just think that this curve has been rotated all the way around y-axis. Something like that. We have a curve, and assume that the right hand, this hand that is moving, it rotates all the way toward that side. And if you think this is a circle, if I just, so this is our point, this is any point on the curve, this point rotates around y-axis, it would make a circle. Now there are infinite many points. These all these points. These are the points for the curve. Obviously, we need to find the volume of shaded region. So then we are going to subtract this volume from this volume. Obviously, that would be the volume of the shaded region. Now we would be rotating the curve around y-axis to find its volume. Now, I already told you that it is going to make a circle. So around y-axis, so it would become volume is equals to integral pi x squared dy, because we are going to rotate it around y-axis. Now, what are the values of x and y? These are in this equation. One value of x and the other value of x. So we have one equation as y is equals to x minus 3. So it would become y plus 3 equals to x. This is our first equation. And our previous equation was x is equals to y squared plus 1. So x is equals to y squared plus 1. So these are our two equations. Now, if we integrate them, this would become, so let's say this is x1 and this is x2. So our x variable would become volume is equals to pi time integral of x1 squared dy minus integral of pi x2 squared dy. Okay. This could be written as volume is equals to pi times y plus 3 whole squared minus y squared plus 1 whole squared dy. Now let's think about the limit of integration. So one value is minus 1 and the other value is plus 2. These are the limit of integration. Let's expand the bracket. So we know that we have a formula which is a plus b whole squared equals to a squared plus 2ab plus b squared. Now we are going to plug this into our equation. So it would become pi integral of minus 1 to 2 y squared plus 6y plus 9 minus 4 plus 2y squared plus 1 dy. It would become pi times minus 1 to 2 negative y4 plus y squared minus 2y squared plus 6y plus 9 minus 1. Now, so if we integrate y4, it would become y5 to the power, y to the power of 5 divided by 5. So it would become pi times y5 by 5 with a negative sign, and plus y squared minus 2y squared would become negative y squared. So it would become negative y cubed by 3. So integral of 6y would become 6y squared by 2. 6y squared by 2 plus 9. 9 minus 1 is 8. So we can just write the integral of 8y. That's it. Now, you may be thinking that why I haven't put the constant of integration. The reason behind it is that it is a definite integral because we have a limit. Even though if let's say I am putting the value of plus c over here, let's say, so when you expand this limit, the c would automatically be cancelled out. I hope the concept is clear. Let us put the limit. So it would become 2 to the power of 5 is negative 32 by 5, negative 8 by 3, 3 fours are 12, plus 16. This is the positive limit. So what I have done, I have plugged plus 2 in the whole equation. Now I'm going to subtract, I'm going to put in the second limit and I'm going to subtract it. So it would become negative 1 by 5, negative 1 by 3, plus 3 plus 8. It is negative 6.4, negative 2.666, 2.667 plus 28 minus 1 by 5 is 0.2. So it would become plus again. Then this would become plus 0.333 plus 11. Obviously, this whole thing is being multiplied by pi. So it would become negative 6.4, negative 2.667 plus 28 minus plus 0.2 plus 0.333 plus 11, 30.466. So the volume of revolution is equal to 30.4665. I hope this concept is clear. Let us discuss what we have done in this problem. We were asked to find the volume of revolution, and we wanted to find the between the region that is highlighted over here. So what I did is I used the equation volume is equals to pi x squared dy. Why pi x squared dy? Because the surface is rotating around y-axis. If it is rotating around x-axis, it would become pi y squared dx. Now I have the two equations which I have written over here. So this is x1 and this one is x2 over here. Then I plugged in the equation into our main volume integral for the volume integral. So it would become pi x1 squared minus pi x2 squared. Then I plugged in the value of x1 and x2, which were in terms of y, obviously. Why in terms of y? Because the subject is rotating around x-axis, y-axis, and we have to plug in the limit of y-axis. So upon putting these values, so x1 was y plus 3 whole squared, and x2 was y squared plus 1 whole squared. So I expand the squared, integrated it, it would become this thing. Later, I plugged in the value limit of integration. After plugging in the limit of integration, I got 30.466. I hope this concept is clear.